Hi Bobcats, today is Tuesday, April 29th. As you come in, please be ready to go when the bell rings. Have a voice level 0, have your notebook out for this class, and a pencil. Today we're going to be looking at unit conversions and taking some focus notes, doing some practice, and hopefully by the end you'll have an understanding of how to convert different unit measures. Here's your planner for the week. You can pause at any time to make sure you get this in your planner and have your DLH for the week of learning happening in our math class. New table of contents filled out for today, which is measurements and data. Not measurements and data, excuse me, measurement conversions. Go ahead and pause at any time if you'd like. All right, let's start with our SBA review. As we kind of remember, we've been doing spiraled review questions to kind of help us make sense of the work that we did at the very beginning of the school year and recall that information. Let's look at the question about Paul and his songs. Paul could play 16 songs on his guitar. He learned some new songs. Now he can play 23 songs. In the first box, enter the equation to represent the number of new songs, S, that Paul learns. In the second box, enter the number of new songs represented by S in the situation. Let's go ahead and mark the text. What do we know? We know that Paul can play 16 songs on his guitar. We know that he now can play 23 songs. In the first box, we're going to come up with an equation. So y equals some number times x, or is it some number plus some number equals 23 songs? Which would be more reasonable? Would I need to multiply 16 by some number to get 23? More than likely, we are going to be adding some numbers together and solving a one-step equation. Okay, now that we've determined that we're going to be using addition, meaning that we're going to set up a one-step equation using the information that we know that he can play 16 songs already on his guitar. So 16 plus some number, we're going to give that number S for songs, equals the amount of songs he knows now, which is 23. Once we have our one-step equation, we can solve this in two different ways. We can say what number plus 16 gives us 23, or we can solve it algebraically using inverse operations. This is positive 16, so the inverse of the opposite to 16 is negative 16. Remember, solving an equation is like keeping it balanced, right? So 16 minus 16 is 0, and we have S equaling 23 minus 16 is 7. So the number of new songs he created were 7 new songs. Okay, go ahead and pause right here for your new left and right hand page and set that up. Also, the do now question that we're going to be looking at is referring to yesterday's guided notes. So if you want to flip back to yesterday's guided notes, once you set up the left and right hand page, that would be amazing. Okay, looking at our do now question, it says a dripping faucet leaks 10 milliliters in 3 minutes, and how many minutes will it take for it to produce 140 milliliters of water? So we're going to write the rate in what we know. It says in the problem that it leaks 10 milliliters in 3 minutes. So let's go ahead and write that. 10 milliliters in 3 minutes. Now we're setting this up in an equivalent ratio. And how do we go now from 10 milliliters over 3 minutes to finding out how long it takes to produce 140 milliliters of water? I'm going to set my equivalent ratio up milliliters to milliliters. So 140 milliliters over question mark. We could put X, we could put any variable there, but I'm just going to draw kind of a little box because that's what I am looking for, is the amount of minutes it takes to produce 140 milliliters. When I look here between 10 and 140, I see that that is a power of 10, which really means that I could divide and move that decimal back one. So I'm really going to take down here and multiply by 14. Here I divided. When I take 14 times 3, I get 42 minutes. At any time, feel free to pause, put this into your guided notes from yesterday. All right, example number 1, proportions and measurements. Remember, an essential question and learning target today is how can I use proportions to solve different unit measures? Today we need to understand what a proportion is and how we use that in different unit measures. So let's take a look at what a proportion is. On your right-hand page, go ahead and write the definition of a proportion. We have a proportion to be known as an equation that shows two ratios that are equal. As you see here, you have 2/8 equals what number over 24? What number do we need to multiply 8 by to get 24? We would times that by 3. So if I times this by 3, I'm going to multiply the top by 3 to get x equals 6. 6/24 simplifies down to 2/8. How many times does what number goes into 6 and 24 equally? Well, that's 3. I can divide by 3 to get 2/8. And that's how we find those equivalent ratios, by using a proportion. You've actually seen that when we looked at our do now and a lot of the rate work that we have been doing with rates and unit rates. When we look at measurement conversions, we're taking measurement conversions that can be converted and representing an equal amount with a different measure of unit. For example, we have inches to feet, grams to kilograms, ounces to pounds. Remember that when you represent the conversion with a proportion, the unit rate or ratio table, you must then solve to find out the rest of the values within that table. So when I look here at this question, it says solve the proportion. A over 3 equals 8 over 1. A over 3 equals 8 over 1. When I go from here to here and here to here, that's actually an A. What do I need to multiply, add, subtract, divide to get the value of A? Well, there are two ways I can do that, a lot of which we've been looking at lately. I can divide by 3 here to get 3 divided by 3 is 1. But how do I find what this value is right here? We use something called cross products, where I have A over 3 equals 8 over 1. And I multiply A times 1, which is just A, and A times, or 3 times 8, which is 24. When I plug that back in for the value of A, I have 24 over 3 equals 8 over 1. So we know that those two ratios are equal, which is what our definition of a proportion is. We're going to watch a short video on what proportions are and how ratios relate to proportions. Now we know a little bit more about proportions and how to work with them in regards to our rates and unit rates and ratios. Remember, our learning target is how can I use proportions to solve different unit measures? As sixth grade students at West Middle School were placed on teams to build race cars in science class. They measure the distance that the race car travels from its starting point. First, let's determine the ratio of inches to feet. Feet to yards and yards to feet. First, we're comparing the unit measures of inches to feet. So how many inches are in 1 foot? Hopefully you said 12, so that ratio would be 12 to 1. When we look at yards to feet, we're comparing feet to yards, and that ratio is 3 feet to 1 yard. Yards to feet, which is the opposite of what I just said, would be 1 to 3. If the team's race car travels 14 feet, then how many inches did it travel? Think about how many inches were in 1 foot. That would be 12. So how did we get 168? When you're looking at, I'm going to go and you have 14 feet that you're given. A team's race car travels 14 feet. How many inches did they travel? Think about how many inches are in 1 foot. 12 inches in 1 foot equals how many inches? How many inches in 14 feet? How did I go from 1 to 14? I multiplied by 14, so I'm doing the same to the top. 12 times 14 should give me 168 inches. Looking at our last example, how could the students use a ratio table to convert 72 inches to feet? Students could set up a ratio table comparing inches to feet. Then they could use the list of the values until they reach 72 inches. You could also say X and Y values if you know that there are 12 inches in 1 foot. You could take the unit rate of 12 over 1 and compare that to 72 over how many feet. How did I go from 12 to 72? You could divide those two numbers. You could build that ratio table and compare those values as well. All right, if we're looking at conversion of units, we represent a conversion of units by using a proportion with the unit rate, and then we cancel those units out through multiplication. So we see here in this example, we have yards to feet, 1 to yards. So yards are going to cancel out here, and I get 3 feet in 1. So when they cancel out, I get 16 over 1 times 3 over 1, which is just 48 feet. Think of Joan. Here we go. Joan is 42 inches tall. What is Joan's height in feet? If Joan is 48 inches tall, Joan is 42 inches tall. What is Joan's height in feet? Think about how many inches are in 1 foot. So we can have inches here, and we could have feet here, we have 12 to 1. Clearly, your different tables will vary, but if I had 24 inches here, that would be 2 feet. If I had 36, that would be 3 feet. That's 36. If I had 48, that would be 4 feet. So Joan is 42 inches tall. What is Joan's height in feet? So setting my proportion up, I could have 12 over 1 equals 42 over x. X is what we're trying to find. We can use cross products. 12 times x equals 42. We could divide by 12, and we get x equals 3.5 feet. Now, that is the same as the rates that we've been setting up when we go like this, and I kind of draw those half circles. I'm trying to find what x is, so I go up to the top and I say, what times 12 is going to give me 42? Well, I know that 12 times 3 is 36, so it has to be greater than 3, but less than 4. So we know that we're going to have to multiply by 3.5. The distance between two cities is 4 kilometers. How many meters apart are the two cities? We have 4 kilometers over x equals 1 kilometer over 1,000 meters. Now I can say, what is going to give me the value of x in this proportion? 1 times x is going to be 1x, or x, and 4 times 1,000 is 4,000 meters. Try working out 3 and 4 on your own using those unit conversions. Hopefully you paused. Here are the answers for 3 and 4. Check your work and see if you're correct. Now on the next slide in the Nearpod, you are going to practice what we've been working on and how you can use proportions to solve different unit measures. Try 5, 6, and 7, and 8 on your own, and then on the next slide or up on the board, you can come check your work to see if you're on the right track. Seek out Ms. Keller or Mr. May if you need help or support working through the problems.